Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
And I'm a cloud solutions architect with Right Brain Networks. I'm your host for today. Joining me is software and data consultant Tom Kowalski.
Hello.
Also joining us is subject matter expert and recurring guest on the podcast, Preston Frazier, a senior software engineer from the Interoperability Institute. Welcome back, Preston.
Thanks, Jason. Happy to be back.
Alrighty, in this episode, we're going to discuss security for serverless architecture, and it is a broad topic, so let's dig in. So yeah, I guess we'll start off with just talking about some primary security concerns for serverless architecture, and I guess I'll toss the first question over to you, Tom. So what security concerns that are specific to serverless architecture, and how do they differ from traditional server-based security challenges?
Kind of putting me on the spot here. So what's the most concerning, are you saying, or like what's?
Yeah, I guess like how do we differentiate from like security challenges that are that apply to architecture in the broader scope versus what's specific to serverless that makes it unique from a security standpoint as opposed to like traditional server-based stuff?
Yeah, I wouldn't say that there's anything that's more of a, bigger threat, right, to security with serverless. As things are more abstracted away, right? There's less that's on your plate that you're concerned with. But with the bigger challenges, I would say is, you don't have access to that server, right? Like a lot of agent-based tools that you may be used to might not work. There's been a lot of changes and things are a lot better, but that's the biggest challenge that I would say is, working with developers. They might have to use different tools to now, navigate through different alerts and findings, and yeah, it'd be some of the biggest challenge.
Yeah, I mean, definitely to follow up on what Tom said, I think, the challenges are still there. We have to remain just as diligent, maybe even more, to make sure that, serverless services we're using, we're implementing the proper security techniques. I wouldn't say there's anything inherent to serverless that's, not existing in a traditional architecture. We still have those challenges. And, I think maybe the challenge is you need to be aware of the security capabilities of each of your services that you're using now, whether it's your cloud storage or your APIs. There's, I think, a lot of settings that you can tweak and tune to secure them to what your company needs or what your job requires. So I think that's really the challenge, in my opinion. But I think we'll dive into some of what those are.
Yeah, absolutely. So I think you guys both touched on the biggest one, which is like securing your architecture without having direct access to the underlying servers or Docker host or whatever. That definitely makes you more dependent on the services provided by your cloud provider that is actually providing these serverless services, right? Like Lambda functions or Fargate or what have you, from the AWS, using AWS as an example there. So yeah, there's definitely more that is put on the provider in terms of the low level part of it. So there's like a shared responsibility, right? There's what's called the shared responsibility model. So yeah, Preston, would you mind going into the shared responsibility model in the context of serverless security and how that impacts developers, organizations, and cloud providers?
Yeah, so I think what you mean by the shared responsibility model is that it's not just the cloud provider, but it's the customer, the people that are implementing the systems, how they operate, manage the components. We are kind of at the limit of configuring these services for what's available. So, we can only, implement the security configurations that are available from the cloud provider. In a lot of cases, there's not opportunities to go beyond that, as maybe there would be in a traditional architecture where you're fully controlling the machines, the servers. You can really install whatever kind of, software you want on them. That's not always the case here. So, from my mind, this model is just kind of to say that you're only as secure as what you implement. And so it's our responsibility to, be using what is available from the cloud provider.
Yeah, just to elaborate on it too, thinking in the context of, what the cloud provider puts out, right, that shared responsibility kind of hierarchy there, you would always see it as, the hardware, definitely, that's the responsibility of the cloud provider to make sure that that's secure, the buildings, facilities, things like that, and then the hypervisor as well. But then if you're running on something like EC2 within that shared responsibility model, now the OS is your responsibility. Whereas, when you're running serverless, it's that little farther up the stack where the cloud provider is, taking on that responsibility of the OS. And it's now more of your responsibility of just kind of that code that's running, right? And its privileges. I guess on that note, right, introducing the one thing it does introduce more of, right, you still have with EC2, but you kind of want to be a little more careful of it, is the privileges of that, your services running, your functions running, and what they can access.
Right, absolutely. Yeah, and kind of along the lines of what you were talking about there, Tom. So being reliant on the cloud provider and then using the tools that the cloud provider gives you to be able to secure your architecture and your environment. Like, do you see the security challenges from a serverless perspective differ much between the different cloud service providers? Or if they do, how much? And what considerations should organizations keep in mind when choosing a specific provider?
I can't speak to too much on different providers, but there's a lot of gray area, especially now, right? When talking about serverless, and sometimes it can get bundled in with containers and different things like that, the different offerings that the cloud providers have. But it kind of depends, right? And how much of is abstracted away, right? Do you have control? You can even run the containers in a Lambda, right? So do you have control of some of that config or not? But yeah, I can't speak too much on the difference Google versus Azure and their different offerings, but just within AWS, right? What can be considered serverless has different configurations and what you can control and can't control, and what's the provider's responsibility.
From my perspective, you certainly get a little bit easier time in organizing the security and permissions. The cloud platforms, they really give you the tools to, I think, really granularly gives different services, different permissions, create sets of permissions. In AWS, thinking about, security groups to control a lot of the network traffic between services. IAM roles that have, kind of a grouping of these permissions for services. Certainly serverless, this kind of architecture. I mean, I wouldn't say, these things are serverless inherent, but a cloud provider gives you this tool to more easily organize security and permissions versus kind of a traditional architecture where everything is not cohesive to one structure of permissions. Kind of permissions are spread all over the place, but with like a cloud provider, you have kind of a consistent way to do permissions for all of your services, which really makes it clear and organized on, how it works and what has access to what.
Right, absolutely. Yeah, so we talked a little bit about, the different resources and tools that cloud providers can give to secure a serverless environment. So I guess let's talk a little bit more about best practices. What do you guys see, and I guess we'll start with you, Tom. What are some essential best practices for securing resources in a serverless environment? And how can developers ensure the integrity of their serverless applications?
I would say one of the biggest things with serverless that you still, have on the other ones is the permissions, right? If it's AWS, it's the IAM, right? And using the least privileges with the things like that. But it allows you to focus even more on the code and your dependencies, right? It's still important if you're running on EC2s, but it allows you to focus more of your, security, how much time, your developers have to focus on those things. It allows them to do that, right? Focus on those dependencies more versus worrying about networking issues and things like that.
Absolutely. Do you have any other best practices in mind that you'd want to talk to or speak to, Preston?
Oh yeah, there's quite a few best practices when it comes to security. I mean, specifically looking at AWS and cloud providers. We've at my company, we've got in the habit of creating security groups for every Lambda function, every service for sure. That gives you a lot of granular control over this function is accessing this other service on the network. Actually, let me back up a bit. I said security group for each function. I meant to say an IAM role for each function. We do reuse security groups between Lambdas, but having an IAM role, a policy for each, function, and then usually each service too. And it's really like the permissions that each service can get. So breaking it out granularly like that, I think really locks you down securely the best. There's tools that can help do that too. Like with serverless framework, there's plugins that can create easily like IAM roles for, each function you deploy. There's tools to help you with that. So that's like internally in your AWS account. Usually you're working in a private, VPC, or your account is a private network. So, most things can talk to each other internally. And then you only want to expose, and this goes for, traditional architectures too. You only want to expose certain pieces to the outside internet that can be accessed. So for those pieces that are externally accessed, you want to be careful with making sure everything is secure in terms of everything has authentication and to what various level you need that. And another great consideration is firewalls. For all of our APIs or even CloudFront distributions, these are two services in AWS that are very internet facing. Client browsers, applications connect to. We have web application firewalls, which is a service in AWS that's essentially a firewall you can put in front of these services, specifically API Gateway, and which handles a lot of your REST API traffic, and CloudFront, which is a CDN, content distribution system for delivering static content. Web application firewalls in front of those are a really great to have thing. They can not only filter traffic, but with AWS, they can prevent things like denial of service attacks. So, if you have, with serverless, here's a good example with serverless, you have services that scale up and scale down based on the amount of traffic that you might have coming through a service. So, something like CloudFront, where you're delivering a static website to a browser, not only do you want to have proper caching control settings there, so you aren't making a bunch of requests out to your S3 bucket, maybe where your static content's hosted, you want to have some kind of firewall there where you can't just have a denial of service attack going on where someone is overly requesting your website and they're blocking it for other people to use. But same thing with the API Gateway. Maybe you're spinning up a bunch of Lambda functions behind your API Gateway, and that could become costly if you're getting a lot of requests that are coming in, and someone is essentially driving up your costs because they're connecting to your API lots of times. Usually, if you have authenticated users who have credentials for these things, the API Gateway side of things, it's going to have authentication on it. Hopefully your authenticated users aren't being, malicious, but if they are, you have that firewall to kind of protect you. Conversely, CloudFront distributions are generally public because they're delivering a publicly delivered, website or static content. So normally there isn't authentication there. So that's really a place where you want to protect yourself with that web application firewall to try to mitigate any attacks. So web application firewall is a great thing for some of these AWS services.
I just want to add to it too, because we kind of talk about the networking, and I think sometimes it gets assumed that, I have to have this, in a VPC and in private. And I think that just kind of spills over from older, networking application architectures where there wasn't authentication or encryption between services that were talking. So, you had to have things in a private network to communicate. But with all of these services, they all expose secure endpoints to connect to, encrypted, right? And authenticated with IAM rules or something else. Sometimes your company may have policies that say that. I encourage you to challenge them if they do. From what I've seen, it's better to have less, right? If you can just focus on, here's the single endpoints, IAM credentials versus open it up to internal network where things might get more lax because, we're, internal and compliance reasons too, right? You may have it in your audit log. I'm no lawyer, but I encourage you to challenge, whether your Lambda functions need to run in a VPC.
Yeah, very interesting. Yeah, it's interesting to see that, these very basic but very relevant security best practices do, they do resonate with serverless architecture, as well as traditional architecture. You have things like the principle of least privilege, which you only open up for a specific component in your application, right? And you're able to do that through IAM roles, with very granular permissions of, what specific, AWS API function for every single service, right? And yeah, just like you guys are talking about with networking as well, only exposing what you need to be able to continue functioning and not just leaving it open to the whole VPC if you're in a VPC. It's just these mainstay principles manifest themselves a little bit differently with serverless, and you've both given some great examples of that. So I guess with using these tools and frameworks that you guys have mentioned, hopefully you'd be able to share a little bit. When implementing these best practices or using these tools, were there any challenges that your organization had faced when doing so, when actually implementing this kind of security for your serverless components and architecture?
Like we've mentioned before, cloud providers add on additional features over time. So sometimes you have a service and, you implement the service and, later on AWS adds a feature in to, add on security, and, you want to use that feature. Sometimes that causes a little bit of re-architecting to happen, but that's kind of the way that these cloud services work. When they implement new features, sometimes that forces you to change your architecture slightly. And so one of the things we do a lot of as well at my company is if a service has encryption, we usually enable encryption on the service for data at rest or for data in transit. One of the things was a later on addition by AWS was for the simple notification service, SNS. They implemented encryption for transport of SNS messages. But to use that, we had to, a part of our architecture was sending SNS messages through our simple queue service, SQS. So part of that was we had to also enable, if you had a encrypted SNS message, you also had your queue have permission to use the encryption key that was used by SNS. So it offered a little bit of a challenge that, we have to go back now and, give permission to some of our queues for allowing them to use the encryption key to decrypt and re-encrypt the SNS message. So it was, a little bit of a refactoring type of thing, but, we were able to do it. But that's kind of the price we paid for utilizing some of these new security features. So it can just cause a little bit of re-architecturing from my view, if you choose, to add these new features on as they go. But that was, kind of one of the hurdle things we came across when we were using a security feature.
Interesting. And so, if you have something like dozens, hundreds, or even thousands of serverless components all communicating together, like how would you enforce those standards that you're adopting, and those changes to your standards? I mean, is there like a formal process that your organization goes through to be able to ensure, I mean, assuming that you're using some kind of something like the serverless framework to be able to do this kind of configuration as code. But yeah, just wanted to hear your thoughts on that in terms of like, if you're able to speak to them.
Yeah, I mean, to the best of my knowledge, what we do is we're able to run reports on services and filter those reports by, what settings are enabled. So we can say list all of the, simple notification service topics that we have, and we can filter out the ones maybe that don't have encryption enabled. Or same thing with another service like SQS. We can run an audit. I'm not sure, maybe it's via CLI. It's probably how it is to do that. Not the simplest thing. I don't think there's a dashboard just to do that in AWS. Sure, there are list screens on each of the services that may show you, if your security setting is enabled or not, depending on what service it is. But, it does take someone going through and looking and auditing in one way or another. And someone has to know, hey, we want to check that this service is encryption enabled, for example. So it's kind of like a manual thing to go through and audit.
Yeah, there are a lot of, it depends on the tools that you're using, right? There's a lot baked into AWS that can give you alerts, or depending on what other security tools that you're using, they can help out by even mitigating, right? Or providing you better reports, dashboards. It's the best thing that I've seen is where you can make it very transparent for the teams and the organization, and kind of putting it on the team of, okay, here, these are the issues, right? That's when things get fixed. So the better you can make things transparent on what's going on, right? Like, hey, these runtimes are out of date, or these are too wide open. If you can make that easier for those developers working on that to see that, there's a lot of benefit to that.
Excellent. So we're getting pretty close to time. We've got just probably another quick question. I was really curious to hear both of your points of view on this. So do you see any trends or emerging technologies or innovations that could significantly impact the future of serverless security?
Well, I think they make it easier too. Like you mentioned, the infrastructure as code tools, they do make it a lot easier to implement these security best practices versus, you having to know, right? It's kind of like they'll do it by default or make it really easy to check a box. And, now it's least privilege and, a different IAM role, like you were saying, for each function. So I think that's a trend of making it even easier by default. And then a lot of these tools, it's not just infrastructure as code, but they're kind of wrapping, kind of doing their own serverless offering, like Vercel, Netlify, where they're abstracting even more. You have even less control, going higher up that model. So I kind of see that, whether Amazon is doing it or, they're not really moving fast enough, right? So there's a lot of providers out there that are making it even more abstracted, right? Just so you can just focus on what you're doing.
Yeah, I do kind of feel like, if it's something that the cloud provider doesn't offer, there's probably a third-party vendor that's working on something if it's, a big enough need. I know one example is that we wanted some static, I guess, antivirus, to scan our S3 buckets to, check for viruses or malicious files. So there's, third-party vendors who you can install their cloud stack in your AWS account, and it'll, scan your buckets for viruses and that kind of thing. That's something that AWS natively doesn't provide. Now, will they provide it in the future? Very possible. It kind of seems like Tom said, the cloud provider, works a little bit slower. I think they work pretty fast still, but they work slower, but they do start implementing a lot of these features into their services. But like the bleeding edge things, brand new, might be provided by a third-party vendor for a little bit, a few years or so. Then you might see that actually get natively built into AWS. So I kind of see that is a bit of a trend. It's really something it's really in hot demand. You'll have a third-party vendor maybe build it first as an installable feature in your account with services. But I want to bring up one more thing too. We didn't get to touch on it, but just real quick, one thing that is built into AWS, it's a really cool tool. It's called Amazon Inspector, and to not necessarily on the infrastructure side, but on the coding side for your packages, like dependency libraries, Lambda layers like that, they do have, code analysis to inspect your code for vulnerabilities. Amazon Inspector. That's a really useful tool that my company uses to help us check if like our code or third-party dependency libraries that we use have vulnerabilities, and that helps report that information to us in a consolidated view. So that is a tool that AWS has to help scan for those vulnerabilities. But again, like we were talking about, they're making changes all the time and implementing things, and usually it's just a matter of time before they offer another, security improvement for a service.
All right, excellent. So we're just about at time, but I just wanted to give a little bit of time for you guys for closing thoughts. So, Tom, any closing thoughts on security in a serverless architecture?
My closing thought would be to make sure it's transparent, right? The findings and everything. It's not helpful to just have your tools, aggregate these and go to a security thing or whatever for your audit reports. Make it transparent and accessible to the developers to see, what are the best practices, what can I improve on, as they're building and making changes.
Excellent. And Preston, closing thoughts?
Yeah, I mean, I think, again, the cloud providers are changing every day, and it is hard to know sometimes those new features that they implement. So it's important to stay vigilant on new features that they're releasing, because that really seems like the best way to have something triggered in your mind that says, oh, they just implemented this feature. Maybe we need to go audit and look at our services again. Because like Tom said, it'd be really great if there was some kind of consolidated view that shows all of your services you're using and kind of gives you this security report that says, well, these security features aren't enabled. They could be enabled to make you more secure. I can see there being the need for that kind of consolidation. But, until that time really comes, keep your eyes open for those new features that are coming, because that'll keep you on, up to date on what's available next.
All right, awesome. Well, I think that's all the time we have for today, but I just wanted to take this opportunity to thank all of our listeners for tuning into today's episode of Lunch with Tech Leaders. Hope you found the conversation informative and valuable, and we would love to have you join us again for next week's episode. As always, the episode will feature expert guests and interactive conversations, so be sure to tune in. Thanks, everybody.
Thank you.